2 today. What we're going to be working on is more information regarding lines, some different scenarios where lines are used. Some of it is just practice situations, get you accustomed to working with lines. Okay. We talked the other day about getting equations to horizontal lines, vertical lines, parallel lines, perpendicular lines. We went down through that whole checklist of stuff. Does that sound familiar? Okay. We ran through all that the other day. Let's say we have a situation where got a little heavier line. Situation where you have 3 points. Let's say we have the point 0, 5. We have the point 0, 0. And we have the point 5, 3. Okay, so we have those 3 points. And what you're asked to do in this, and realistically, a P&G, would they ever ask you to do what we're going to do here? No. However, it's good practice on working with these. What they ask you to do here is to draw a series of lines. So, for example, the one line passes through here. The other line passes through there. And I'm going to move that 5, 3 over a little bit. Okay. A third line passes through here. And a fourth one like that. So that what you have are 4 lines, 2 of them parallel in each direction, 2 of them perpendicular in each direction. So this is going to give you some practice with slopes and parallel lines and perpendicular lines and all that good stuff, isn't it? Wow. Where would you start on this anyway? Is there an obvious start point to do this problem?
I would start with 0, 0, and 5.
Yeah. How about we call that line 1? If we compute line 1, we have all the information we need because we have the 2 points. We have 0, 0, and we have 5, 3. Can you do the slope from that? Yeah. And I'm going to do the slope leading with the point 5, 3, because then when I put the origin in for the other one, it's minus 0 and minus 0. So right away, it's pretty straightforward that the slope is 3/5. Does that make sense? Now for each of these, I'm going to use a fairly quick way to get the equation of the line. In each case, I'm going to use y equals mx plus b. Using that, m is going to be 3/5. For the x and the y, all you need to do is to choose one of the 2 points to plug in for x and plug in for y. Which of the 2 points on this line would be easier to use? 0, 0 would, wouldn't it? If we plug 0 in for y, and we plug a 0 in for x plus b, right away everything zeroes out. What's b have to equal? 0. This gives us then that b equals 0. And the equation of our line, let's see, I'll put them in a different color. Maybe make it stand out a little better. The equation of the line is going to be y equals the slope 3/5 x plus b, but b is 0. So there is, bless you, the equation for line 1. Now from line 1, we can then pretty easily get line 2. We already know some information about line 2. What do we know about line 2? It's parallel to line 1. If they're parallel, any idea what that'll get you? If they're parallel, what's the same? The slope. Oh. Okay, so line 2 is parallel to line 1, which means that the slope is going to be 3/5. Does that notation make sense? The two tall, skinny lines means parallel. So line 2 is parallel to line 1. So its slope has to be the same 3/5. We also know that on line 2, there is a point 0.05. Once again, we can use this y equals mx plus b. The slope is going to be 3/5, and I'm going to use the x value, 0, plus b, and a y value of, what's the y value? 5. So this gives us that b equals 5. The equation of this line is going to be y equals 3/5 x plus 5, where our b value is right there. Well, that's got those two done. Where do we go from here? Let's say this is line 3, and this is line 4. Which line should we do next? Or does it really make any difference? Each of them has a point on it. So let's just go ahead and do line 3 as our next play. Now, line 3 is not parallel to either line 1 or line 2, but line 3 is perpendicular to line 1. Is line 3 also perpendicular to line 2? Yeah. By being perpendicular, that tells us what the slope is. To get the perpendicular slope, what do? You flip it and take the negative. So if the other slope had a value of 3/5, this is going to be negative, and then you do the reciprocal 5/3. On line 3, do we know what one of the points is? 0, 0, isn't it? Well, that's enough information to go ahead and cook this up. Once again, using y equals mx plus b, we can substitute in our value for slope, and we're going to have a negative 5/3. The x value from our point is 0. Excuse me. Thank you. Plus b. The y value is 0. So what's b's value going to be here? It's going to be 0, isn't it? Wow, this is coming apart pretty quickly, isn't it? It's just kind of a quick way to review some of the information. So this is going to give us y equals a negative 5/3 x. The b value is 0, so you could put plus 0 if you wanted to, but don't necessarily need to. That leaves us with one last line. That's line 4. Well, line 4 is parallel to line 3, which means it's also going to have a slope of a negative 5/3. Everybody okay? I know I'm going kind of fast. Line 4 has this point 5/3. So what we can do then is we can use this point 5/3, and we're going to use y equals a negative 5/3 x plus b, and we can substitute in the 3 for the y value, the 5 for the x value. You're going to have 3 equals a negative 5/3 times 5 plus b. Uh-oh, this one's going to be messy, isn't it? Got to multiply by fractions and add fractions. This looks like fun. So we're going to have 3 equals a negative 25/3 plus b. What's the next move here?
Convert 3 into a fraction.
We can convert 3 into a fraction. Boom, there it is. Now it's a fraction, but we need to tweak it a bit, don't we? What do we need to do to it? Please? Yeah. Yeah, we'll get to that in a little bit. We'll keep things all good and proper here in a bit. Okay? But the first thing we have to do is we have to get a common to combine the two fractions, don't we? So we're going to multiply this by 3 over 3. So that's going to give us 9 over 3. And then we can add this to each side, which will give us plus 25 over 3 is equal to b. Anybody lost? B then is going to work out to have the value 34 thirds. Now, Myron was saying we need to get this back as a proper fraction because it's an improper fraction now. Okay? And that's it, depending on what direction you're going to go, that makes sense. If we were going to buy this many gallons of paint, I don't think anybody's going to walk into Menards and say, I need 34 thirds of a gallon of paint. True? Probably going to say, like, I need 11 and a third, which would really be 12 gallons of paint. Have a little extra, it's never a problem. Okay. But if, on the other hand, we're just doing math with it, is it easier to work with 34 thirds or to work with 11 and 1/3 if we're going to be multiplying, dividing, adding, and subtracting? Yeah, it's easier to work with the improper. So the reason that we'll see improper fractions at times is depending on what's coming up next. Okay. If I'm going to be at a really nice dinner, depending on what my job is, I'm going to be wearing a suit and tie, or maybe roll out the tux. Or if I'm going to be in the back doing dishes, am I going to wear a tux? No, I'm going to need to look a little different, aren't I? Okay? So depending on the job that it has ahead of it is how you decide which form you want it in. For this, I would be inclined to leave it as the improper, because when you add and subtract stuff, because when you have an equation, and we're going to get this equation, y equals a negative 5 over 3x, plus, if I put this 34 thirds, now when we plug in a value for x, like 7, we get a negative 35 over 3 plus 34 over 3. We're ready to go, aren't we? Okay, we don't need to get a common denominator or any of that stuff. So it depends on what way you're moving with it next. Either is a legit answer. I will take either. And I'm not going to worry about it. The question is, which is going to be less work for you? And that's something you're going to have to think about each time to make the decision on which way you want to go. Does that make sense? Parallel lines, perpendicular lines, all that good stuff. Okay. Let's take a look at an example. Let's say we have something like this, some information. Did we do the music download problem the other day? I'm thinking we did. Yeah. Okay. Yeah, that's what I'm thinking. Let's take a look at another one. Let's say that we have car shipments. And these are shipments from a particular production facility or a particular company, and they're shipping around the world. So let's say that this company in 2013 shipped 69 million cars. In 2015, they shipped 75 million. In 2017, they shipped 81 million. And in 2019, they are on target to ship a total of 88 million cars for the year. What would you estimate your shipping to be for next year? Okay, so here we have some car shipment data over a period of years. Looks like the company is continuing to grow. Looks like the shipments are increasing year to year. And we want to be able to predict into the future, what kind of shipments can we expect in the future? What should our sales look like? Because you're planning 3, 5, 7 years out. You can't just decide I'm going to build a car and get all the equipment, the parts, the raw materials together in a couple of weeks. Okay? So to get an estimate on this, what we first need to do is to graph the data and see what the shipments looks like. Is it a straight line or what's going on with it? Well, before we do that, we got to figure out, am I going to put the years or the number of cars on the x-axis? And the question there then is the x value, the independent value, the year or the number of cars? And sometimes an easier way to ask this is to look at the other way. The y value is dependent. Read it like this. Does the year it is depend on how many cars are shipped? Or does the number of cars shipped depend on what year it is? Which controls the other? Does the shipment control what year it is? No. The year controls the shipment. So it's the year that's in control. That means that is your independent, your x variable. The total units moved is your y value. Does that make sense? If you get those backwards, everything from there on in is messed up. Okay, so for my independent, I'm going to put that's the year. And then over here is going to be cars in terms of millions. Now, let's see here. I'll do 13 about here, 15, 17, 19, like that. 69. How about we try 60 down here, 70 about there, 80 about there, 90 about there. This is million cars. Okay, and year, this is going to be in the 2000s. Are you good? So now it's time to plot these puppies. 2013, 69 million. 2015, 75 million. Yeah, if you like cars, look up the new Corvette, the 2020. 19 is going to be, this should be 1990 here, not 1999 or 99. Are you okay? What's that data look like? It forms? Does it look pretty linear to you? Okay. It does to me as well. So what I'm thinking I might do is just say, let's fit this to the equation of a line. Something kind of like that. Now, we need to get the equation. It's going to be a linear equation. For a linear equation, we need a slope first, don't we? How are we going to get the slope? Yeah, use a couple of points. Does it make much difference which 2 points we pick? Nah, not here. So we could pick the point. I'm going to use 1369. And let's say 17. Well, let's say 19. And then the 88. Could you have used 2013 and 2019? You could. By using 13 and 19, it just makes the slope and the numbers smaller to work with. Okay? Okay, so to compute the slope here, the slope is going to be one of the points minus the other. I think I'll do the 88 in 2019 minus the 69 in the 2013. That looks like that's going to give us about 19 over 6. Is that about what you're coming up with? Probably okay there? There's our slope. Will it reduce any? Doesn't look like it. This would be 3 1/6 if we wanted to do it with a proper fraction or mixed number. Okay, next thing I want to do is I want to get an equation. It's going to be y equals, and I'm going to leave this as 19 over 6, then x value plus b. Which of those two numbers up there should we use? Should we use 13 and 69, or should we use 19 and 88? Or does it really look like it's going to make much difference? They're both looking kind of ugly to me. So what I'm thinking is I'll just go with the smaller one. So I'm going to plug in the 69 equals the 19 over 6 times the 13 plus the b. Anybody lost? Now we're going to go ahead and solve for b. Let's see here. Got the calculator right there. So first thing I'm going to do is take the 19 times the 13, and that's going to give us 247 over 6 plus b equals, I'm going to do the 69 times 6, which will be 414 over 6. Do you see what I did there on the left side? Does that make sense? I went ahead and I got a common denominator, because I know this 69 is really 69 over 1, and I'm going to need a fraction with a 6 in the denominator to combine those two. Okay? So then what we're going to do is we're going to take this 414 over 6 minus 247 over 6 equals b. So b is going to be equal to something or other over 6. So it's going to be the 414 minus the 247. Aha, 167. Now, this may be an equation unlike many or any you've ever seen before. What our equation is going to look like is going to be y equals, and the slope is the 19 over 6, x, plus the b value, 167 over 6. Anybody lost? Okay. Yes, sir. Okay, what formula? This is the slope-intercept, because it has the slope there in front of the x, and the 167 over 6 is the y-intercept. Now, at this point, you got to be careful, because if you're asked to estimate shipments in 2022, and I just picked that number. So if you're wondering where do you get 2022, I just pulled a number out of my head. When you plug it in, what are we going to plug in for the x value? 2022? 22? Let's try it each way, just to see what happens. Our y value equals 19 over 6. Now we're just experimenting. If we try the 2022 plus the 167 over 6, this is going to give us, we have 19, there we go, 19 times 2022 equals, this is going to give us 38,418 over 6 plus 167 over 6, which is going to work out to be 38,585 over 6. So if I divide that by 6, that's going to be 6430.83. Well, let's think about that for a minute. Based on the data that we're given, does 6430 look like a reasonable number moving on down the track? If we were to go 2 years, if I would have asked you to guess what's happening in 2 years, from 69 to 75, from here to here is a jump of about how much? About 6, isn't it? From here to here is a jump of about 6. From here to here is a jump of about 7. This would be a jump of about 6 or 7. So maybe this would be 95 million. Well, yeah, but we've got another year here. That's true. We're jumping 7 every 2 years. True? So we would do maybe a jump of about half of 6 or 7, another 3, which gives about 98 million in that year. Does that make sense? So looking at things this way, it looks like it should be around 98. What are the units on this number? Is this just 6,430 cars this year? Well, the Y value is in terms of millions. Whoa! So this is going to be this many million cars. That's right. If you were to write this out, this is going to be 6,430,000,000. Now remember, with million, you move the decimal 6 places. So I'm going to do my 830,000,000. Does that sound reasonable? You know what that says? 3 years from now, you're going to make and sell enough cars that every human being on the planet buys a car from you. That's a growing company. Okay? You know, there is a company that makes enough product each year for everybody in the world to have one. You know what that company is? Campbell's Soup. Campbell's Soup makes about 7 billion cans a year. What's the world's population? About 7 billion. Campbell's Soup makes enough cans for every man, woman, and child on the planet to have a can of soup every year. That's kind of amazing, isn't it? Okay. So, if this was Campbell's Soup, it would sound reasonable, but for cars, maybe not so much. Okay, so let's go back. And let's take a look at where we started this. We started it here where we're going to estimate the shipments in 2022. We've tried this on. This feels like it's a little bit too big, doesn't it? Okay, that's fine. We can try stuff on. The important part is to decide, does it work? This is too big. Notice no screaming, hollering, or anything. It's just too big. Put it back. What are we going to try next? Well, let's see. What did we try before? We tried putting in 2022. What are we going to try this time? 22. Because remember when we were doing our x values, remember here on the graph and over here on the slope, our x values were just the last 2 digits, weren't they? So we have to be careful. When we plug our numbers in, we're going to want y equals 19 over 6 times 22 plus 167 over 6. Now let's see where that gets us. We're just experimenting. Okay, so I'm going to take 19 times 22 equals. So this is going to give us 418 over 6 plus 167 over 6, which is going to give you 585 over 6. And if we do that division, this is going to give us 97.5. Okay, so you try that number on. Does that seem to fit pretty well? Yeah, that's a pretty good fit, because when we were talking up here, just looking at the table, just based on the table, it looked like we were going to be selling about how many? About 98 million. That's pretty close to 98 million. That one fits. We'll buy it. Does that make sense? It's okay to try numbers. Just remember, when you plug them in, the thing to ask yourself is, does this leave me with an answer that makes sense? Okay? Always come back to, does this make sense? Okay. On your calculators, do you know how to do a linear regression? Say what? Can they cure that? Let's take a look at how you do a linear regression on the calculator. Now, you may also want to go to YouTube. Okay? They have lots of movies on there on linear regression with a TI-83. Linear regression with a TI-84. Okay? So when you get home and you say, oh crud, I forgot what button to push next, this will get it done for you. Okay? We've got about 10 minutes. Let's take a run out, see if we can get something going here. Okay, I'm going to move over to the document camera. And in the movie, all you're going to hear from or see from this point out basically is the conversation that we're going to have. All right. Does everybody have a calculator or somebody sitting by where they can see the calculator? Uh-oh. This means Friday you got to be able to do this on the calculator for the quiz, doesn't it? If you don't have one of these, is there any way to get one? No, I don't mean go out and spend $110. Oh, they have them at the library where you can borrow them for a couple hours. You just go up to the desk where you check out the books, and they've got them. No way, I didn't know that. Just remember to bring it back. You got to turn in your driver's license or something like that. Something of value. Maybe your car keys, so you're definitely not going anywhere without them. Okay? How does this work? Let's use a couple of points. Okay? Let's use the points. I'm going to write it down on the computer. Then I'll write it on the board. So that you got it to look at in the movie. Let's take a look at the points. 1, 1. 2, 3. And 3, 4. Okay? You could hand draw a graph for that. We could do a graph of it on here. But what I'm interested in doing with this is to just kind of quickly move you through how to do the regression. And just know from the start that it's linear. Okay, so the first thing to do is turn this thing on. I'm pressing clear to clean up my home screen. And how many people have like an 83 with them? Okay. So that would be a lot of people needing to get an 83 for Friday, wouldn't it? How many of you do have an 83 somewhere? Okay. That's not a whole lot. Please? Oh, how many people have a TI-83 or 84 at home or something? You can use the 84 or the 83. Either one will work. Yeah, they're the same thing. Let's skip this because, well, let's see. Did the class said a scientific calculator, didn't it? On the syllabus, or did it say graphing calculator? I forget which. Scientific calculator. Okay. Okay, I was hoping more had it. Don't worry about it. We'll skip it. If you're headed to calculus, which I don't think was a huge number, but if you're headed to calculus, get on YouTube and look up how to use this thing to graph. Because in calculus, it's just going to be automatically assumed that you're up and running, which also means that you're going to need to get one. Okay. So what let's do then is we'll just skip that for right now. If you had those 3 points, could you get the equation of a line? Yeah. What you could do is graph them. 1, 1, over 2 up 3, over 3 up 4 would be something like that. And I would be tempted to use the 2 points on the ends to get the slope. Okay, so the slope is going to be 4 over 3 minus 1 over 1. So that looks like it's going to be about 3 over 2. So we have y equals 3 over 2x plus b. Now, look at the 2 points that were used to determine the slope. They were the points 1, 1 and 3, 4. You've got to plug one of those 2 points into this equation. Which would be the easier to work with, 1, 1 or 3, 4? Yeah, let's just go with 1, 1. So we're going to plug in 1 for y, 1 for x, plus b. So what we're going to have is 1 minus 3 halves equals b. What's 1 minus 3 halves? 1 half, and it's going to be negative. Good. Equals b. So this gives us then the equation is going to be y equals 3 halves x minus 1 half. Everybody good? So you can still get the equation of the line, can't you? It's not the end of the world if you don't have the calculator. Okay. You need to be aware that there are more than just linear equations in the world. Okay. You have seen, and this is moving into section 2.2, you have seen lots of equations like y equals 4x plus 7. How many variables are in that equation? There are 2. There's x and y. You have seen equations like this. 3x plus 5 equals 2x minus 9. How many variables are there in that equation? There's 1. It's just x. It appears more than once, that's true, but there's just one equation. You have seen equations with no variables in them. No variables? Really? How about 2 times 8 minus 4? What's that equal? 12. Well, there's an equation. It has an equal sign. How many variables? None. Now, one of the things that can get really interesting is if you were, for example, doing a profit function for Kroger's, every separate product has a different product or profit margin, doesn't it? So if you were doing a profit, you would have to say like $1 per box of Corn Flakes, 75 cents per box of Cocoa Puffs, and you would have to have the profit for each item times how many of that item. But how many items does Kroger's carry? Gee, many. Have you ever thought of it item by item by item? How many separate items do they carry? There's a lot, aren't there? When you get into a lot, you can't use ABC anymore because there's only 26 variables. And you're going to need more than 26 for Kroger's. So what they do then is they go into variables like this. x1, x2, x3. And let's say the profit on this is $1. The profit on this is 70 cents. The profit on this is a nickel. How many variables do you have now? Where does this stop? It never does it? You go all the way to infinity with this. So you can have an equation with 0, 1, 2, up to infinity different variables. One of the classes that I used to teach here, they don't offer it here anymore. Some of the last problems at the end of the semester had 70 variables in them. You would have an equation with 70 different variables in it. And you'd have maybe 40 different equations. And you'd have to solve that mess. We'd use a computer. Okay? That that makes more sense. Okay? But realize that equations don't just have to be y equals mx plus b. They can get a lot more entertaining than that. Okay? Friday, what's the quiz going to cover? It'll cover up through 2.1. Okay? And let's see, before that was section 1.4, which was, I think, on last week's quiz. We'll finish off 2.2 hopefully on Friday. But let's look at 2.1 for Friday's quiz. Okay? Folks, I hope you have a good day. I'll see you.